Hello, and in this video I'd like to introduce a new technology that's been developed for the PixelGameEngine. A new platform has been added that allows us to compile the PixelGameEngine applications without much change to WebAssembly. This allows us to run them in an internet browser. And before I demonstrate how this is done, it's imperative that I must thank the community for putting this together. So in no particular order, I wish to thank Magetsub, Dandestein, Morris1138, Slavka, Gorbit and Bispu, who have all played a role at some point during the life cycle of this project. Personally, I think the ability to run PixelGameEngine applications in the browser is game-changing for the PixelGameEngine project. And so this video is just to show you how to set up the environment required to compile your applications. Before we can get compiling in the browser, we're going to need a project that compiles on the desktop. And so I'm going to very quickly create one. Here, I'm creating a new blank C++ project in Visual Studio. To this project, I'm going to check its properties, and for all configurations and all platforms under the General tab, I'm going to set the C++ language standard to C++17. Then, I'm going to add a new source file to our project, and I'll call this one starfield.cpp. Using a file explorer to navigate to the project directory, I'm going to paste in a copy of my PixelGameEngine header file. How you connect the header file to your project is entirely up to you, and different people have different ways of doing it. To get things working for an internet browser though, you will need a PixelGameEngine 2.15 or above. Since this video isn't about creating a project specifically, I've prepared some code in advance. But this is a programming YouTube channel, let's have a quick look at it anyway. I'm going to start by simply displaying a star field, like the old Windows screensavers. And in my PixelGameEngine derived class, I've created a structure, star. Stars travel at a speed, they have a distance away from the center of the screen, and they have an angle. It's going to look as if we're flying through space. All of my stars are stored in this vector of stars. I'm going to be creating lots of random floating point numbers, so I've created a convenience function to allow me to do just that. I can specify a range. In onUserCreate, which is called at the start of the application, I resize my vector of stars to the number of stars I want it to hold, and then I go and create a whole bunch of randomly positioned stars. Before we start the application, I quickly cache the center point of the screen. In the onUserUpdate function, which is called every frame, the first thing I do is clear everything to black, because space is pretty dark. I then use a little auto for loop to iterate through all of the stars, and I update the distance of the star, depending on its speed, and how much time has elapsed since the previous frame. I also introduce a small non-linearity, and we need that to get the pseudo 3D effect of the stars. In principle, when they are further away, they look like they're travelling slower. If a star reaches a certain threshold, in this case 200, then the star is completely randomly generated again. Finally, I use the angle of the star to create a unit vector. I change the length of that unit vector by multiplying by its distance, and I offset that position by adding it to the origin, which is the middle of the screen. Finally, I take the star's initial colour, and I also add a small non-linearity to that too. In principle, this will make the stars look a little bit darker as they're further away. And that's it. The only thing left is our int main, where I create an instance of our starfield class. I construct a window of 256 by 240 pixels, and each in-game pixel is going to be 4 by 4 screen pixels by default, and I start the application. Very short, very simple, let's take a look. And here we have a rather satisfying star field simulation. It's as if we're travelling through space. It's nice. And it has a compelling pseudo 3D effect. We could change the colours around and use exactly the same setup to make it look like we're travelling underwater or through other mediums that has dust particles floating about within. However, today it's space. Starting with PixelGameEngine version 2.15, the header file is now sensitive to an additional platform and compilation environment. It's called Emscripten. The Emscripten platform implementation currently resides at the end of the header file, and it looks a little different to some of the others. The first thing that looks a little strange is the presence of some JavaScript inside the header file. Yes, I know. But it's necessary to make sure that the PixelGameEngine can handle the environment changing size. The Emscripten API is a little bit strange, but the community have gone to great efforts to make sure that it does accurately reflect the behaviour of a desktop Pixel Game Engine application. As with all things PGE, we simply don't care how these things are implemented, it should just work. So how do we compile our application now and run it in a browser? Well, firstly you need to head on over to emscripten.org and click on this Download and Install the SDK button. Now, a word of warning. Typically, output on the One Lone Coder channel and the Pixel Game Engine applications are aimed at a beginner to intermediate level of capability amongst programmers. As much as possible, I've tried to design the platform in such a way that you don't really need to be familiar with compiler toolchains in order to use it successfully. However, at the moment there's no getting away from this for Emscripten. I'm sure the community will put together certain build files, and as we'll see at the end of this video, I too have created some utilities to help us build web applications a little more smoothly. This installation page for Emscripten is actually very well written, and if you're reasonably competent at following instructions, you'll have no problem getting it running. The instructions show two ways of installing the software development kit. The first is via Git, but the route I chose, because I'm not a big fan of Git, was to download the SDK and run the commands in a command prompt. And their instructions even cater for people like me. In order to install Emscripten in the first place, you're going to need Python installed as well. So head on over now to python.org and download and install Python if you don't have it already. Emscripten uses Python as, well, sort of an install management tool. There aren't actually a great many instructions to follow, so once it's set up, I recommend that you head over to the EM SDK directory that you've created, which is where you've installed Emscripten in the first place. And on Windows at least, I like to click on emcommandprompt.bat. This sets up a command line interface that's ready to go compiling Emscripten applications. If you are familiar with compiling on Linux, then a lot of this will be second nature to you. Instead of G++, it's EM++. And we can see it behaves just like a regular C++ compiler. I'm going to navigate to the project directory. Here we can see the CPP file we've just created in Visual Studio. Let's have a go at compiling the star field. It's quite a long command to type out by hand. Firstly, we need to specify that we're using C++ 17, and I'm not debugging. Because the Emscripten compiler is going to be compiling code for a guest environment within a guest environment, there are restrictions on what it is allowed to do, and we can hint to the compiler what rules we'd like it to follow. The first rule is I want it to allow memory growth. This means our Pixel Game Engine application is actually allowed to allocate memory. Next, we need to tell it which version of WebGL it should be using, and we do this with the max WebGL version parameter and the min WebGL version parameter. The Emscripten installation comes preloaded with lots of libraries that have been ported to work in the Emscripten environment. This is very useful for things like sound and networking, but the Pixel Game Engine specifically requires that something can load sprites and images. And on the Pixel Game Engine we use PNG files. And on Linux, by default, we use libpng. So I can tell the Emscripten compiler that in fact, if you have libpng lying around, please use it. Now I want to specify the name of our source file. And finally, I'm going to specify the output name, which rather bizarrely is an HTML file. I'm going to call this one pge.html. Let's try that. One of the things Emscripten will do is automatically make sure all of its libraries are up to date when you start a compile task. It will then compile and cache things as necessary for this project, so subsequent compiles can happen a lot more quickly. If you think it's frozen on your first compile, don't worry, it does just take a little bit of time. Well, we didn't get any error messages, and maybe that's to be expected because our Visual Studio solution compiled flawlessly anyway. Now if we go and interrogate our Starfield project folder, we can see it's created some files. One of these files is called pge.html, that was our output file, and two additional files, one that contains some JavaScript and one that contains the WebAssembly. Now at this point it's very tempting to just go and double click on the pge.html file, but it's not going to work. As you can see here, I just double clicked on it and nothing is happening, it stalls. That's because my computer doesn't have a server serving me these HTML files. Fortunately, Emscripten comes with a utility called emrun, which will sort of virtually create a server environment for you. So let's try this. And straight away, there we go, there is our star field running in one of the tabs of my browser. It has a template provided by Emscripten. At the bottom here, this is console output, so if we did something like standard cout, the results would appear down here. We've also got some buttons at the top. So if I uncheck lock and hide the mouse pointer and click the full screen button, we can see it's done exactly what we expected it to do. It's gone full screen. Press escape, and we can go back to a normal size. In fact, the PixelGameEngine for Emscripten is sensitive to sizing. And just because I thought it would be neat, here is the desktop version of the star field and the browser version of the star field running simultaneously. In the PixelGameEngine repo on GitHub, you'll see a new folder, which is dedicated to the utilities required for the WASM compilations. One of these is an HTML file called basic template. By default, this file is pre-configured to look for PGE.js. And so if I use emrun to run this basic template HTML file instead, we can see the star field is now the only thing in our browser window. It still changes size too, which is pretty neat. The .wasm file contains all of the WebAssembly code. In fact, you can go and have a look at it. It doesn't make much sense, but it's there. What isn't there is any additional assets that our project might use, things such as images and sounds. Emscripten behaves slightly differently in this regard. In fact, it behaves quite similarly to the OLC resource pack, if you've used those. As part of our compilation process, we will instruct Emscripten to create a single file, which is in effect a virtual file system. And this is quite a neat way of doing things, because it means we don't have to change our code when we're running on the desktop or in the browser. But to make our lives simpler from the very beginning, what I'm going to do is create a new folder and simply call it assets. This folder will now effectively be the root of our virtual file system. So for example, in this folder I'm going to create another folder called graphics. And into this folder I'm going to add this image. Going back to our original program, I'm now going to load that image. I'm going to load it as a renderable. And we'll do our loading in onUserCreate, remembering that we're now relative to this assets folder. After I've drawn the star field, I'm going to draw this logo at the location of my mouse cursor. And I'm going to draw the logo as a decal. So let's take a look on the desktop. Nice, that's working. In fact, I'm also going to change its size a little bit, make it a bit smaller, and I want to make it a little bit transparent. I'm going to use the floating point pixel format for this. We'll keep it tinted white, but I'm going to set the alpha component to, well, 0.6. So let's take another look on the desktop. Very nice. We can see that's working just fine. This time, when we're compiling with Emscripten, we also want to get it to create this virtual file system. So here is the command from before. I'll also specify the starfield CPP file. Again, set our output to pge.html. And this is the important bit. We had another argument called preload file, conveniently split across two lines there. And to that, we pass in the root of our file system. In this case, it's our assets subfolder. Press enter to compile, and it should compile a lot more quickly this time. In fact, that was it. Rather disappointingly, you don't get any output. But what we can see in our project folder now is we also have a pge.data file. Just as before, I'm going to use the basic template to run our application with emrun. And we can see it's loaded the graphic and it behaves in just the same way as before. It may be very tempting to think that you should now just go and convert all of your PixelGameEngine applications to work in the browser, and I would encourage you to at least have a go. But there are some things the platform can't do just yet. And that's because myself and the community haven't gotten around to making sure that all of the extensions to the PixelGameEngine are compatible with this Emscripten platform. So things like the networking series currently going on, that's not going to work directly. Nor is anything that's going to use PegX sound. However, there has been work performed on using the gamepads. And so like most of this project, it's currently very much a work in progress. And I will emphasize that if you have any problems setting this up or getting started with it, don't complain on YouTube or on GitHub, come to the Discord and talk to the people that can genuinely answer your questions. Using Emscripten isn't trivial and it does have some caveats. But now that we can create Emscripten-based web applications, there's one last cool thing we can do. Back in the project folder, I'm going to select my basic template, my data, my JS file, and my WASM file. And I'm going to compress all of those into a zipped folder, pge.zip. A popular game jam platform is itch.io. We've used it many times on this channel. And one of the nice things about itch.io is it allows you to use WebAssembly-based projects. So let's create a new project. We shall call this one Test WASM. And the kind of project, we're going to choose an HTML. You have a zip or HTML file that will be played in the browser. Because this is the One Lone Coder channel, no payments are required. And I'll upload the file. There's our zip. It's uploading. And I'm going to select this file will be played in the browser. Under Embed Options, I'm going to specify a viewport dimension. Now, I have to be a bit careful here to make sure that I kind of match the aspect ratio I'm expecting the application to run at. Currently, it's a 4:3 aspect ratio. So I'm going to change my viewport to match that aspect ratio, 512 by 480. Then I'll choose Automatically Start on Page Load, and I'll try this mobile-friendly option. There is a limited degree of touch support provided by the Emscripten platform. Finally, let's save and view the page. Oh dear, we've made a mistake. It says it's looking for an index.html file, so we'll need to change that. Let's take our basic template and rename it to index.html. I'm then going to add that to our zip file and re-upload. Well, you can't get everything right. Let's try that again. Saved, and I'm going to view the page, loading game for the first time, and there we go. On the itch.io page, we've got our web application running just fine. This means we can now use the One Lone Coder PixelGameEngine in-game jams quite happily, and people don't have to download a dodgy executable which your antivirus is going to scare them about. And in fact, here is Magetsub's entry to a jam last year, Burb Attack. This is actually written in the PixelGameEngine. And don't assume just because it's running in the browser that it's going to run with terrible performance. Here is the Spyro the Dragon level I created as part of the Code It Yourself 3D engine, except now it's rendered at 720p in the browser. Now this final bit is for the Visual Studio users only. I don't particularly like using the command line each time I want to compile, so I've created a small utility which you can integrate into Visual Studio, which will specifically compile PixelGameEngine projects using Emscripten. I can go up to Tools, and I can choose Emscripten Compile Target. I've got my CPP file selected. And we can see it does some Emscripten stuff at the bottom. In fact, it'll go through all of that compilation phase again, and produce the same output as before. Once it has finished building, you can then go to Tools and Emscripten Run. It will automatically launch the browser and launch the application. Very convenient for debugging without going out of Visual Studio. The way this works is through a small batch file utility called PGE WASM that I've created. This batch file needs to be primed with some information, such as where have you installed Emscripten, and where do you keep your PixelGameEngine header file. Just so happens that on my machine I keep it in this particular development directory because that's where I build and work on the PixelGameEngine file. Typically though, if like in our Starfield application it's in your project folder, you could just set its location to be there. Like with all batch files you download off the internet, do have a look at it to make sure it's not doing anything nasty before you run it. But in principle, it will search to make sure that those two folder locations are legitimate, and the bat file takes some additional parameters. One is build, another is run, and the final one is clean. It works in a similar way to a makefile. Build will start the Emscripten environment and set all of the environment variables for the compiler. It will then go and grab the C++ files that it can find in that folder, or a specific file. That depends on whether you're compiling everything or compiling a specific CPP file. It then checks to see if an assets folder exists in that environment. If it does, it will compile it with the command we saw before that includes this preload file argument. If not, it doesn't bother with doing anything with virtual file systems. If you choose the run option, well, all this does is call emrun and links to our PixelGameEngine HTML file. All of the WebAssembly stuff is created in a subdirectory called WASM. If I now go back to our project folder, we can see this WASM folder has been created. This is the output of my tool for Visual Studio. Don't confuse it with the output we created by hand before. To integrate the BAT file with Visual Studio, go to Tools and select External Tools. This brings up a menu where you can create the 4 tools that I'm using. The compile tool, well, we'll give it the title Emscripten compile, and the command that we're passing to it is the path to our BAT file, wherever you've decided to put that. The only argument I need to provide to this is build, because that's exactly what this compile function should do, and we'll tell it to work in the project directory. So that's the same folder as our Visual Studio environment. For compile target, which compiles a specific CPP file only, the command is exactly the same, but this time our arguments are build and the properties of the target file we've selected, in this case starfield and .cpp. Again, the project directory is set. For run, we just call exactly the same BAT file, but we specify the run argument. And for clean, same again, but the clean argument. I like to see what the output is, because if you do have errors, they will pop up in the Visual Studio output window. And when you're done, click Apply and OK, and this puts the tools there ready for you to use. And that's really all I want to show for this video. Again, I really want to thank the community for developing this platform. I think it is game-changing for the PixelGameEngine. The ability to now use this engine in online competitions and distribute the end results to your friends and family and whoever, without requiring them to install things first, I think is really important, and a fantastic achievement by the guys that have made this. As with all new software, and particularly all new one-lone coder software, there will be some bugs, and as it's now revealed to the community, no doubt these bugs will start coming in thick and fast, and we will do our best to try and fix them. But if you do have problems, I urge you to come to the Discord server to discuss them. I probably won't pay any attention to GitHub comments or YouTube comments specifically about problems setting up Emscripten. Now, finally, in a few weeks' time, I've not yet settled on a specific date, I think I'm going to have a One Lone Coder jam where you have to use the Emscripten version of the PixelGameEngine. Let me know what your thoughts are about that on the comments below. If you've enjoyed this video, give me a big thumbs up please, have a think about subscribing, come and have a chat on the Discord server, and I urge you to have a go at compiling your PixelGameEngine applications for your web browser. Take care.